we can integrate partial fractions by using decomposition. So I know you're thinking, man, you know, we did this decomposition stuff in pre-cal, but I didn't think that I was going to have to see it again. Well, this is part of it. We've always been able to split up a numerator, but partial fractions, a decomposition process allows us to basically split up a denominator and come up with these individual fractions that I can integrate. Okay, this is not something that I know how to integrate, but if I can split it up into two separate fractions, then I can. So remember, there's a method called the Heaviside cover-up method. I don't teach it that way just because I would like to have you have more of an algebra base, I guess. But there is another method called the cover-up method. If you want to look it up, it's pretty straightforward. But I'm just going to teach you real straightforward reminders of how to work with decomposition. So remember, first of all, I put my therefore before I wrote out my sentence. Okay, first of all, we're going to multiply both sides. We're going to factor, because we've got to work with the separate factors that we're working on. Okay, multiply both sides by the denominator. On the left, then what I mean by that is from the original function. So remember, whenever we were working with linear situations, if I have two linear functions here, I'm going to split that up into a and b. So then I'm going to multiply both sides by this denominator that was in the original function. And then this was what it would look like. If I multiplied both sides by that, remember, I can multiply both sides by anything I want, and then mathematically I'm multiplying, they're equivalent to one another, both sides are. So I'm multiplying by an equivalent of 1. So this would be a times x minus 2 plus b times x minus 3. So what happens here is if I multiply this side by all of this, then for a, I have an x minus 2 left because the x minus 3 ends up canceling out. And for b, the x minus 2 ends up canceling out, so I have the x minus 3 with it. So that's how I end up with that. And we're going to pick convenient values. So we would pick a 2. That would get rid of this piece, and a 3, and that would get rid of this piece. So we're going to pick convenient values for x. And solve for a, b. You could have a c and a d, or whatever it may be. Now, I will say that this piece is what you will be tested on the AP test, this idea of linear factors in the denominator. We do need to be comfortable with working with repeated factors. So this idea of a repeated linear factor that is x and that is an x squared. And then you also have the idea of unfactorable quadratics that we have to work with as well. So remember, whenever we split this up, these are the factors that will multiply together. So those are going to be my two denominators. But anytime you work with the quadratic, when you decompose it, what's going to go in the numerator is going to be a linear function, not a constant. So I will have two different variables that I'm solving for here. So you have an a, b, and a c. So you need to be familiar. We're going to do an example of each one. But you need to be familiar with these three pieces so that you'll be able to work with the integration concept of them.